One of the ways that we can draw more logical conclusions to deductive arguments is to study a few of the common forms that these deductive arguments take. So if you're ever wondering why one type of conclusion seems valid and another does not, or if you are struggling to figure out what type of conclusion is being asked for in a certain case, this can be helpful. So one of the common forms of a deductive argument is called the law of syllogism, or sometimes called the law of detachment. And this is the form of the argument. The first premise looks like an if-then statement. It will be if something, then something else. And we tend to use the letters P and Q to represent those statements. So if P, then Q. And the second premise is P. So in other words, now it's not an if anymore. It would take the form of just a definite statement. P has happened or P is true. So those would be the two premises. And from there we would draw the conclusion. And in this form of the argument, the conclusion that we're looking for is Q. And that's considered to be a valid argument. So if you look at the worksheet that you just completed, numbers 3 and 4 take this form. Now we need to do a little bit of rewriting to make them fit this, and then the form becomes clear. So let's take that first sentence, and I'm just going to assume for the sake of pronunciation here that some of these consonants maybe are silent in this made-up word. So let's say that the first sentence there is a skiffig is a thigursi with a long tail. So I could rephrase that and put it into that if-then form of a sentence by saying, if it is a skiffig, then it is a thigursi with a long tail. And then the second statement, Rilton is a skiffig. So if you look at these two premises, well, the first one, if P, then Q. So what is P? Well, P is, it is a skiffig, that's P. Okay? And then Q, it is a thigursi with a long tail. So that's that second part there. That's the Q, or the second statement in that first premise. Okay. Then moving on to the second premise, Rilton is a skiffig. Well, this is just a different way of saying P. It's more specific, so it's kind of like a minor premise, right? But we're referring to Rilton, which falls into that category of P. It is some sort of skiffig, right? So that's like P. So then the conclusion we're looking for is just Q, but in this case I would also want to make it more specific. So instead of just saying it, I would replace that with Rilton. So the conclusion then would be that Rilton is a thigursi with a long tail. Okay, and that's Q. Now, second example would be number 4 on that worksheet that you just completed. And in this case, the first statement is already in that if-then type form. If a number is not divisible by 3, so that's P, then it's not divisible by 9. So that second part is Q. It's not divisible by 9. And then our second premise essentially says the same thing as P, it just says it more specifically. It says that the number 14 is not divisible by 3. So that's the P, and then what conclusion are we looking for? Well, the conclusion we're looking for would just be Q. That would be a valid conclusion. So I would want to just rephrase Q, but make it more specific to 14 rather than just a number in general. So my conclusion would be that 14 is not divisible by 9. Okay, let's look at a second form of a deductive argument. This one is called the law of contraposition. And when we get to the logic portion of the course, we'll talk more about this one and explain where that name comes from. But for now, just know that the form of this argument looks like a premise that's if P, then Q. And that's followed by a premise that says the opposite of P, okay, so not P or the opposite of P, and then the valid conclusion to that, oh, I'm sorry, not Q. Okay, so the opposite of the Q part of that first premise. And then the conclusion is not P. And we'll look later in the course at why this is a valid logical argument and see some examples. But for now, this may be helpful to just know that this form exists and help us know what type of conclusion we're being asked to find. So if you look at numbers 1 and 2 on the worksheet you just completed, both of those take this form if we do a little bit of rephrasing to get the sentences to look like if and then then. All right, so if we look at number 1, the first premise is that passengers must have a passport to board an international flight. So if we rephrase that so that it's an if-then sentence, what we're really saying is if a passenger wants to board an international flight, then he must have a passport. So that's another way to rephrase that rule. Now the second premise is you're traveling from America to France and you forget your passport at home. So we could take the second part of that sentence, you forget your passport at home, and we could rephrase that, you do not have a passport. So notice that that sentence is like the not Q, right? So that's sort of like the opposite of having a passport. So then the conclusion would be not P, or it would be the opposite of boarding an international flight. So the other part of that premise, you're traveling from America to France, just gives us a way to make a more specific conclusion here. So you could say something like, you will not be able to board that flight from America to France. Now notice we did have to do quite a bit of rewording here to make this fit the argument, and that's one of the disadvantages at looking at verbal examples rather than maybe mathematical examples with equations and things like that, because there is some room for error here depending on the way you rephrase this. It's possible that you might not quite capture the idea of that conclusion. And it's also possible that you might have come to a different conclusion, like maybe something like you'll need to return home to get your passport or something like that. So that's kind of the difference between maybe a mathematical form of reasoning versus a non-mathematical. So there are other things that you might conclude in this case, but if you're being asked to draw a logical conclusion to an argument, then generally you're being asked to find something that fits into one of these forms. All right, so it must be, first of all, related to the premises. So let's make a list here. So related to the premises. And it needs to follow deductively, meaning it needs to be inevitable or certain or some sort of necessary thing that we would have to conclude based on those premises. And generally the best way to figure out what that piece of information is to look at one of those forms of logical arguments. So it might follow the law of syllogism, it might follow the law of contraposition, or some other form of deductive argument that we haven't studied yet. All right, so there are many things that you might conclude that could be true or reasonable or likely, but if you're asked to draw a logical or a valid conclusion, this is what we're looking for. Now there is one more example on the worksheet that I did not look at, the cows one. So as practice on your own, or maybe you want to discuss this with some classmates, you might want to see if you could take number 2, the all cows have 3 legs example, and see if you can rewrite that argument so that it sort of fits this form, the law of contraposition form. So if something, then something else, and then not something, so therefore not something else. And then one final thought on forms of deductive arguments, notice here that the conclusions and sometimes the premises may not be true. So you may have picked this up at some point in some of those readings that you did earlier, but I just want to really emphasize this, that that deductive does not necessarily mean true. Okay, so it would be more correct to say that deductive arguments are valid or logical, but they may not be true or sound. Okay? And the same could be said for inductive reasoning. Inductive does not necessarily mean true or false. In that type of reasoning, we're looking more at likely or probable versus unlikely, not probable, right, or strong versus weak. We're not really talking about true or false at all in that context.